Let me see if I can show it. Guys, see my screen?
Yeah.
Yeah.
Okay, so I know that because you were not in the first session, right? The study group session, and you were there in the second one. Just a quick recap, right? So we kind of started with understanding the very basic things. In telecom, what does it mean by switching, transmission, and signaling, right? And we looked at different evolution of the network, starting from PSTN network, how you evolved from the basic PSTN network to the signaling and the trunk split of by bringing in the new technology called SS7 at that point of time. So we kind of discussed about how the evolution from the basic PSTN network to the advanced PSTN network, which provided the advanced services, intelligent services like toll-free, prepaid. We talked about that. In parallel, we were also trying to understand the data network side of it, how things evolved from mainframes all the way to the different advanced computers that we have today, as well as we try to understand the transport technologies evolution. And the bottom line is today, most of the networks are all IP-based networks, right?
Okay.
Then we went back in our journey of many years, the very basic thing that we learned, the protocol stack OSI model, we kind of went through that. And then we kind of touched bases on, okay, this is the model and there are a number of protocols came into the picture.
Mickey,
yeah.
Can you hear Kader?
Yeah.
Okay.
Sorry, I speak in mute. Yeah, I can hear him fine.
Are you okay,
Okay,
Vikas?
Yes.
Let me see if I can enhance something here. Just a minute. You will be able to hear me better if I do this. Can you hear me better now?
Yes.
Yeah.
Hello?
Can you
hear me?
Yeah.
Yes.
Yes.
Hi, Sammy.
Hello. I just joined the meeting. It's my first time in this in this meeting, so I don't know no one.
Where are you? From which place did you join from?
Now I'm in France in
Norway. Okay. All right.
Yeah.
So what do you do, Sammy?
And you are where are you exactly?
I'm based of Toronto, Canada.
Canada. Okay. At this time, I look for a job. I was working at Nokia in Paris.
Okay.
In Bell Labs, I worked on the Cloud Run.
Okay.
On Cloud Run with radio and in the research department of Nokia at Bell Labs. And now I want to move to the south of France in Nice area, Sofia Antipolis, Cannes. So I I travel and I found this Magma opportunity because I'm a developer. So I joined to see if I can work in like software independent.
Yeah, that's really good.
Or I don't know how. I don't know.
Yeah, no worries. So I'll explain about what we are doing here. I also see Javier is joined. Javier, where are you? From which place have you joined?
For which place? You mean?
No, I'm asking Javier. I understood you are from France, Norway, and then now you want to move to Niche. And there is another gentleman joined the call. So I was just wondering if he wants to speak and introduce himself.
Okay. Thank you.
His name is Javier. Javier, are you there? Can you hear me? No. Okay. All right. So let's continue this. This is our third session, Sami and everyone. So I'm just giving a recap to the team. First of all, what we try to do is we want to come together and learn 5G together, right? This program, we have not advertised it. We just wanted to, form an initial group of people who wants to learn 5G, and we wanted to slowly grow, right? We don't want to have many people in the first round. So this is our third session. We will send you the link for the first two sessions that we learned together. Study group concept is we wanted to come together and learn 5G together. So one thing that we chose to learn together is Magma. But before we start learning Magma, we wanted to learn something together, which are basics of telecom and stuff like that, so that we can better understand the Magma and start working on Magma, right? So that's the thought process. So we will also have sessions of Magma from different people once we go through this basic telecommunication related stuff, studying together, right? So that's the thought process. Okay, so can we get started? Apologies, I just need to get started. We have 30 minutes, so is it all okay, Sammy? You understood?
Microphone. Yes, I understood. Yes.
Okay, so I'm just I was just trying to give a recap to the team that we learned together in our last session. So we learned together the basics of telecom, switching, transmission, signaling, and we learned together the evolution of the PSTN network by providing very basic voice service to SM, to advanced, intelligent network services like
Public switch, telecom network. Yes.
and so on. So we learned this together in our last session. Then we also learned together the data network evolution, right, from the mainframe and how it all became to IP, all IP now, right? So we learned that together, how the data networks are connected in the enterprises through switches, routers, and connected to the ISPs for internet access and so on.
Yes, yes.
Right? And we also learned together in our previous session the very basic engineering stuff, right? OSI model, and kind of started brainstorming about how the data network started supporting voice, right? So we talked about voice over IP, service evolution from the basic H.323 protocols to the SIP protocol at a very high level. So the message here was how the data network started providing. I couldn't hear what you said. How the data network started providing the voice services, and how the legacy telecom network, which was supporting ATM, TDM, how they kind of adapted towards all IP slowly, one step after another, by adopting the Cictron stack, and eventually now we are in the world of IP stack, right? So that's something that we discussed. So we discussed about the PSTN network, data network, how it evolved, and also we kind of touched bases and understood about what is a transport network, right? So if you wanted to connect to people locally or internationally, you need to have a transport network. So it's very critical that we understand, of course, this also had multiple technologies now. Nowadays, it's mostly all IP technologies. So how we are all connected from the transport point of view / transmission point of view is something that we kind of discussed. So we had a premise, then we have metro access, metro core, long haul, right? These are all some of the terms that are used in telecom world to kind of connect the people in a more layered way. Like local, states and provinces, then countries, between countries, and things like that, right? So we talked about that. Then we talked about the basics of cloud, because all these things are very important before we jump into Magma, because Magma adopts the latest technologies. It is ground up built for edge deployments, and it is built to run on cloud, on containers and VMs. So it's very important that we understand the basics of these, right? So that's why we kind of started learning in our last session what is the cloud, what are all the different types of cloud, private, hybrid, public, and community clouds, and how the services industry transformed the way that it was providing the services to all as a service model, right? Nowadays, we even have procedure as a service. You don't even have to write the functions anymore, right? Function as a service. You just have to call an API. It will do everything for you. Like in the past, nowadays we just have to. You remember in those days we used to write programs. We have a main programs, then we have a lot of sub programs. Nowadays we don't even have to write sub programs. We just have to write the main programs and call the sub programs that are available as a service, right? So things are evolved from basic providing the hardware to even providing the level of functions over many years. That's the world that we are living in. So then we also learned about SDN. What is it, right? It's basically mostly focused on transport, right? It's to ensure that you don't have a heavyweight transport routers and devices that are very heavyweight, and you can use a simple technology, SDN technology, that can help you to separate in those. When I say heavyweight, what do I mean by that is, see, router, it used to do both control planes and the data plane related activities. So the difference between the control plane and data plane is, we discussed last time in a very simplest term, some messages goes back and forth to set up the connection, and the data plane is the actual data that you pass, can be a voice or internet browsing or whatever, right? So when I said heavyweight transport equipments, in the past, those transport equipments, they used multiple different protocols, and they supported both control plane and data plane within that device, right? Now this SDN, what it did was, it kind of separated the control plane and the data plane using SDN technology, so-called as, right? It used protocols like OpenFlow. So you have a control plane in the top that controls multiple bare metals, dumb switches, right? Or dumb boxes, transport boxes, in a simplest way to say it. So the master controls all the dumb transport boxes and allows the traffic from user A to user B pass through those dumb boxes, right? And most of the intelligence are on the control plane. So that's what the SDN is all about. So the main thing that you need to kind of understand is that, so the cloud allowed us initially to deploy a lot of, instead of me deploying all the applications in the office or enterprise, it allowed us to deploy all the applications in the cloud, and we don't have to put a lot of capital expenditures to build the IT infrastructure in the enterprise. So that's the disruption and innovation cloud brought. So what it enabled is, it enabled innovation, right? And people, small startups, are able to do things that was not possible before, right? As an example, if you take a technology called WebRTC, if you know, and if you do go and research something, you can actually become a service provider providing voice, data, and text services to your customer by yourself, which was not possible before, right? The big guys only can actually provide those services, voice, video, and data. Now WebRTC technology allows you to do that by just hosting that in the cloud. Well, there may be a problem with the qualities and latencies and stuff like that, but definitely it has a market that you can go behind, right? So that's what cloud enabled. Cloud allowed us to reduce the capital expenditures and increase the flexibility, increase the innovation, so we can run applications on the cloud. On the other hand, on the transport network, SDN brought in major changes, right? It reduced the cost of heavyweight transport equipment to less cost by separating the control plane and user plane, which is open source. There's a lot of, like, Open Daylight is a SDN controller. You can actually go and look at it, right? It's open source. So you can build your transport network through a central management by deploying a cheap transport equipments to transport the data from one user to another user, whichever part of the world that he is in. So that's SDN, right? So these two really disrupted the industry. This up to last slide, we learned together in our last session, right? So today, for next 15 to 20 minutes, what we are going to learn is network function virtualization. So I will stop here for any questions from anyone, or if anyone wants to share anything.
Kurt, I just want to let them know that I put the WhatsApp group like we always do on the chat.
Yeah, okay. So, Sammy and Javier, there is a WhatsApp group here for this particular 5G study group. You can join that WhatsApp group, right? And we can communicate there as well. And also there is a Microsoft Teams. You can send your first name, last name. We can add you into the Microsoft Teams to kind of discuss offline as well. Okay. All right. So let's take a break before we learn a new concept today, NFV, and then we will jump into 5G. So once that is done, then we will jump into Magma, right? So today's session and next session we are going to continue to learn the basics that will help us to, put the right mindset and right knowledge base, which can allow us to jump into Magma and start doing coding, understanding the coding, GitHub, deployments, and number of things that we will learn together. It's also, again, a super thing, right? Because see, think about it. In the past, these 5G core networks, 4G core networks, radios, this was all built by big companies. It was impossible for us to learn. And only way that we can learn them was working in those companies, right? But nowadays we have Open RAN, Open Core, which is what we are going to learn first, Magma, right? And after we finish learning Magma, then we will have a new session where we probably will learn Open RAN together. But the thought process is these things helps us and reduces the barrier to entry into learning things, experimenting things, and start doing consulting around that. As an independent consultant, or even join the company, right? To help the companies to grow. I mean, these kind of opportunities never was there before 10 years, 15 years, whatever, right? In our early days. So now it's an opportunity. So we should leverage those opportunities and we should start learning together. So that's the thought process. All right. So I have here again, Bean, Javier, do you want to kind of unmute and introduce yourself before we start learning NFV together for next 15 minutes? No? You're shy? Okay. All right, Sani, go ahead, please. You want to say something?
Yes, I cannot find the chat on my application. I use a MacBook, and this on the Teams I don't see the little chat where you have put the meeting chat. I don't have the option. I don't have the button.
Oh, okay. So
can I put my email somewhere and receive the? How can I do? Because
yeah, I'm also thinking, if you can't see the chat, how can we communicate?
yes, it's difficult.
So do one thing. Tell me your phone number.
Yes,
we will add you into that group. Nikki, can you write down his phone number? Yeah.
Yeah.
I just have sent you a contact on LinkedIn.
You sent me? Okay, let me check.
Yes, so you will have all my information.
So I don't see you. Did you send an invite or Sammy?
That's me.
Okay.
That's so there is my
your phone number here, so I will ask.
Mail and yes, yes.
So you are a DevOps, is it?
I was yes, yes, I yes, DevOps, yes. As independent, yes, I know how to write code, Python, C, C++, and I know how to use Kubernetes, Docker, VMs.
Send me your resume, okay? Just I want to keep it in my records, and there may be a lot of opportunities that we can work together. Send me your resume, okay?
Yes, this is my resume. Yes.
Yeah, but send me your
Ah, okay.
I will give you my email address, father@createlabs.ai. Yeah, you can send it to me.
Okay.
And also please send it to your resume to this, and your you can type your phone number in this Teams, right? Sorry, in the LinkedIn, so that I can ask Mickey to add you into the WhatsApp group, and then we can communicate there.
Yes.
Okay, so let's continue. All right, we have a few more minutes, and our goal is this session and next session. After next session, we need to jump into Magma. So let's get this going. Mickey, you can make, if you want, all the videos public. Okay.
Okay, yeah, I'll do it later today.
Sure, understood. All right, so let's learn what is the NFV. It's called as Network Function Virtualization. Okay, so by name itself, it's very easy to understand. Network function. So what is network function, right? So in the telecom world, we had multiple devices, equipments that connected two people to talk, or connected a people to browse, right? Talk with the machines to browse, and different terminals, IoT devices, machine to machine, enabled to. So there's number of devices in between that connects people to people, people to machine, and machine to machine. Okay, and those devices, again, it's the same concept as SDN, right? In SDN, the transport devices are very expensive. So SDN technology brought in innovation to split the control plane and user plane from that heavyweight transport device. So the transport related cost can be reduced, managed, and delivered services to the customers. So that's SDN, right? But when it comes to NFV, right? NFV, what it did, other than the transport devices, right? If you go back to this diagram here, there is something here called as, these are all the transport devices, right? Other devices or equipments, however you say it as. On top of that, you also have other equipments that actually telecom equipments that provides the actual telecom services. Like for example, if you wanted to provide voice over IP services, you need a session border controller, you need an IMS, CSCFs, HSS. There are a number of devices that you need that sits here, right? Which provides, which takes the control from the users and then sends it to the other users. Now, all these devices are connected by the transport network. That's why you see this here in the down. So the transport network connects all these devices, and transport devices also connected through wires and cables and wireless, depending upon whichever the technology you are in. So the SDN addresses this, the transport part of it, bringing innovation and separating the control planes and user planes. But what happened was the actual equipment, right? 4G network functions. It's called as equipment is called as the network functions, right? In telecom world. So in this area, okay. So those network functions that are provided in this area, that was again provided by big vendors, right? And they provided both hardware and software bundled together, and they sold it. But what happened is, over the period of time, in the telecom market, they started realizing that the hyperscales, when I say hyperscales, it means like AWS, Google, they are all called as hyperscales, right? That's the term that is being used. So the telecom world started looking at Google of the world and Amazon of the world, and they started seeing, okay, I mean, these guys, they don't buy these kind of expensive equipments from big vendors that has software and hardware. They buy hardware separately from the vendors, and they put software on top of that in the cloud, and they are running it in a cheap way. And that is why they are able to also provide the services in a much cheaper way. You think about it, right? I mean, the voice calls from Skype is free. WhatsApp calls from WhatsApp is free. I mean, how are they able to provide it? Because the cost of running the network is not that expensive for them, right? Because of they adopted the cloud. Yes, there will be quality issues and stuff like that, but the cost was tremendously low, and that's why they were able to provide these services for free. But of course, they make other revenues like advertisement, for example, Google search, for example, Google, right? They make other ways, they make money in other ways because end of the day, everyone has to make money. But when it comes to the communications, particularly, it became commodity, it became free. So what happened was that kind of impacted the telecom providers, right? Like, for example, before when I want to call my parents back in India, I used to do an international call, right? And it used to be expensive for me 20 years ago, 25 years ago. And now I just take a WhatsApp and I call them and it costs me $0 other than monthly internet charge that I pay. Right? So what happens? What is the end result of all these things, right? End result of all these things is that the users like you and me wanted to have things that are cheaper, but we want more for less. Let me put it that way. That's the right word to say it. Now, in that case, how a telecom operator can make money? They cannot, it's very difficult, right? 20 years ago, I remember I used to pay for the phone $200. Now I pay like $30, right? But I use 300 times more data compared to what I used to use in the past. So think about it from the telecom operators like Rogers, Bell, AT&T in Norway, right? Think about it. How can they make money, right? If the users are paying less and they want more. So that means the only way for them is to reduce the cost. So what are all the different things that can help them to reduce the cost? Moving to cloud where applicable. Some of the applications they can move to cloud and reduce the transport cost by moving to the technology, which is SDN. And likewise, they wanted to reduce the cost on this area, right? The network functions area. The physical network function is called as physical network function. Why? Because you go to Nokia, Ericsson, Huawei, or whichever the vendors that are out there, you go and buy from them, both hardware and software, right? So that's why it's called as physical network functions. Then NFV helped the telecom operators to build virtual network functions. So that means you don't need to buy the hardware and software from the same vendor. You can buy the hardware from HP's, Dell's, and all these people. You don't need to buy a proprietary hardware, right? You can buy commercial off-the-shelf hardware that are available from all these people, and then buy only the software from Nokia's and Ericsson and run it. So it reduces the cost. And also brings innovation. It's not only about the cost, brings innovation. If you are able to separate, disaggregate the network, you can kind of adjust your network architecture depending upon the customer use cases very innovatively, right? So all the technologies that we discussed also brings in innovation, brings in agility, brings in spending money only what is required to be spent. Like for example, you can, if in the morning only 10, let's say you have a network in your city and you operate it. In the morning, during 9 to 10, you know that your network requires 10 Gbps throughput, okay? Then in the afternoon, evening, and in the night, probably it requires only 500 Mbps of throughput. Then why do you spend money to deploy 100, 10 Gbps of network? You can kind of put the virtual machines or containers in the night to support 500 Mbps. In the morning, scale up vertical or horizontal to support 10 Gbps. And then in the night, again, reduce the resources. So see, you use it when you need it, right? So these are all the innovations that you can bring in developing and designing the networks and serving your customers, right? Using all these technologies, cloud, SDN. And NFV is no different, right? Like I said, all the devices like, session border controllers, SGSN, GGSN, brass, and all these things, right? So now you can convert all these things into software and buy only software from them and deploy it in the cloud, whether it is a regionally cloud or a national cloud or an edge cloud. So that's a different story, right? You can deploy the cloud closer to the users and away from the users, depending upon the use cases. But the bottom line is, one line to remember what NFV is: definition, network function virtualization, meaning you are virtualizing the network functions and you're taking the software and you're putting it into the hardware. So what you're essentially trying to do is you're separating the hardware from the software. That's what the network function virtualization is all about. Okay, so if I kind of summarize this at a very high level, right? Cloud is all about moving away from on-premise investment to cheaper investment. And SDN is all about reducing the transport cost by separating the control plane from the user plane, the transport control plane protocols from the user plane protocols. Then NFV is all about not buying any more an expensive equipment from the vendors, just buy the software from them and buy a hardware from different vendors so you can reduce the cost and improve the innovations, agility, and many other things. So if you bring cloud, SDN, and NFV together, right, it's all software networks, pretty much. Yes, every software requires an hardware to run, but now you're not going to buy the proprietary hardware. You're buying a commercial off-the-shelf hardware, which you know how to manage it, right? The hyperscales like Google has been managing for more than decades and decades, right? So we can learn a lot of things from there, and we can manage stuff, right? So that's what the cloud, SDN, and NFV is all about from the definition point of view. But what's more important is for you guys to understand is, yeah, this is what I said, right? It increases the innovation, NFV reduces the capital expenditures, the SDN abstracts, and everything brings in innovation, right? So bringing all these things together is actually a good thing to do. Now, for today, one more thing that I wanted to really see, these are the 2 slides that I wanted to go through, 3, 4 slides, 5, and then we will start on the cellular network in our next session. And then we'll finish the basics of cellular network. Then we will start on the Magma from probably starting next year onwards, right? The actual coding of the Magma. And why you need to know all these things? Because all these things are part of Magma in one or other way, okay? Like for example, Magma uses an SDN principle to separate the control plane to the user plane. And Magma software runs in VMs, network function virtualization. And Magma software runs in cloud, like AWS. Magma software runs in containers, like Kubernetes, right? So all these basics for you to understand is very critical. Now, the most important thing here that I wanted you all to understand is, okay, now you know what's the difference between cloud, SDN, and NFV. And NFV is you wanted to virtualize the network functions. But today in the cloud, AWS has their own management entity that manages everything, right? Google has their own management entity that manages everything. Likewise, Microsoft, right? But in the telecom world, what happens is, but all those are proprietary, right? They have built their own way of doing things, but they're all proprietary way of doing things. But one thing in telecom world is that whatever that they do, they try to do it in a more standardized way. So what happens is they define this is how it has to be done. The standards like HC, 3GPP, and many other standards, right? They define this is how it should be done. This is how telecom cloud networks has to be managed, right? And they define, and then what happens is different vendors build their products as per that standard definition. So it's very important that we understand what standard defines from the NFV point of view. But you don't have to understand that from Google Cloud and all. You just have to know how to use them, right? Because everything is proprietary. And the same story, like WhatsApp. Can you connect? Can I make a call from my landline to the WhatsApp phone number? I can't. Why? Because WhatsApp uses proprietary protocols, more or less. But I can pick up a phone and I can call my mom's phone I would say in India, right? So in India, it is provided, let's say, by Reliance, and here the service is provided by Rogers. But I can talk between Rogers and Reliance. But can I talk between Skype and WhatsApp? No. Can I talk between WhatsApp and Google Chat? No. Right? Why? Because the reason behind that is in the telecom world, whatever that they build standards, and everybody goes back and implements it based on that standards. So all the devices globally can work together. So you have an interoperable system that is available. Okay, so that's very important to kind of understand. So from that point of view, even how the telecom cloud has to be managed is being defined by European Telecommunication Standard Institution. It's called as HC. So they define and they continue to define the NFV architecture. And based on this, all the telecom equipment vendors and everybody goes and builds their product and they come back, right? So that's what it is. Now let's understand what is this at a very high level. This is very critical. Even when you are talking about Magma, I'll tell you, I'll try to connect that Magma to here, right? It's very important to kind of understand. So when you look at a cloud, what do you need? Let's go from the bottom up, right? What do you need in the bottom is the hardware. It should have a compute, it should have a storage, and it should have a network. Then what do you need on top of the hardware? A virtualization layer that manages, that hides the details of the hardware and manages these hardwares and creates the virtual compute, storage, and network so you can use them. So this is what happened even in AWS, right? What do you do when you go and buy? They provide you the virtual VM to you, virtual machine to you, right? In the past, we used to go and buy a physical machines, right? Like laptop, desktop, and so on, right? Now, when you go to Amazon, what they're giving you is they're giving you the same thing. It has CPU, memory, and everything, but they are giving it to you like a virtual one, right? It's not a real equipment, right? You don't see them. It is abstracted. The details are abstracted from you. That is why it's called as virtual. Virtual means don't think it's coming something from nowhere, right? The virtual definition is nothing but it abstracts the details, how the hardware is managed. That is why the name virtual is for. Okay, so they provide virtual computing, virtual storage, and virtual network. So this is called as network function virtualization infrastructure. So which has a hardware, which has a virtualization layer that provides the virtual resources to you. I'll give you an example. This hardware could be from Dell, HP, or anyone. Virtualization is nothing but your hypervisor, right? It could be a KVM hypervisor, Zen hypervisor, EXSI hypervisor, and so on, right? And when you put that hypervisor and manage these hardwares, you should be able to create a virtual resource. And you can provide the virtual resource to the next level, who can install their application. So in the cloud, you install website. In telecom, you install the network functions like software, software MME, software P gateway. So what you do is, this is called as virtual network functions. That's nothing but a VM. You install the network functions into it, so it becomes virtual network function. So up to here, it is same as in the cloud, right? Even in the cloud, you do this and you provide the VM, you install website. Here, you install the network function. But there is a little bit more in telecom in the sense that every network functions that are deployed has their own management entity. Always, right? Like if you are installing a router, it has its own management. Why is this management entity? It's called as an element management, okay, by definition. Why do you require this? But if you want to configure this VM, if you want to understand the health of this VM and things like that. So anything that is not the virtual functions, network function, anything that you wanted to know about network functions, you will get to know through the management entity of that network functions. And that management entity is nothing but element management. So in the Magma context, if you consider the whole Magma converged core network as a network function, as an example, then Magma has something called as an orchestrator that you can consider it as an element management function. Or sometimes you can call it as, you can consider that as a NMS also, right? I'll tell you the difference between EMS, NMS, and OSS in little after. But for now, kind of understand that there is a management entity that manages your network function. Even in Magma, there is a management entity that allows you to manage your Magma converged core from the point of view of instantiation, configuration, collecting the events logs, and all those kind of things. So you need a management function, right? Now, one step above, if you go in telecom network, you need to manage all these things, right? That's called as OSS, operating support system. It's very, very important to understand. Even in Amazon and Google, you have it. You have a dashboard. You can actually go and look at how much CPU is coming, how much memory is doing, what is this, my website is doing, how many hits, and things like that you can know from even from Amazon and Azure statistics, right? You can monitor the operation functionality of your infrastructure, virtual infrastructure, and so on. So likewise, in telecom world also, you need to monitor not only the hardware, software, the virtual infrastructure, but also you need to monitor all the network functions, right? So all these things are monitored and corrective actions are taken, which in something called as an operating support system. The name itself says it's not very difficult to kind of remember. It's operating support system. So it helps in, it's a support system that helps in operating the network. Very simple to understand, right? Then in telecom, you also have BSS, right? When we go and buy a phone, we have to pay monthly to Rogers, AT&T, and so on, right? So someone has to track how much usage that you are doing it, and if it is a prepaid, postpaid, and they have to send you the bill and detect your money from your bank, and send a PDF of billing, whether through the mail or through soft copy through email. I mean, the whole process, understanding the inventory, there's a number of things, right? The business support systems, the name itself says, right? In order to run marketing sometimes, right? Identifying and defining the right packages, a combination of packages during the, during the festive season. So you need a support system to run your business. So that's nothing but BSS. So in a telecom network, you need this, right? The telecom network without OSS, without BSS, you can't build the customer. Without OSS, you cannot make sure that you're running the telecom network in a better way. It's very, very important to kind of understand. Okay, so now you have these four things, right? But all these four things has to be managed and orchestrated. That's what is in the right hand side, right? So you need something that can manage and orchestrate the virtual network function virtualization infrastructure. So that is nothing but virtual infrastructure manager. If you are using OpenStack here, the OpenStack is, you can consider it as a virtual infrastructure manager, which manages the OpenStack, let's say KVM or whatever that hypervisor that you have, and it manages the software and hardware. It allows you to define and provide the virtual machine to the next level, so they can install network functions, right? So you can consider OpenStack as a virtual infrastructure manager, right, which manages the complete network function virtualization infrastructure that includes hardware, hypervisor, and the virtual storage, compute, and network, and provides the VM to the next layer. So when the VM is provided, so in the VM, you're going to install the network functions like MMEs, P gateways, routers, and you're going to build the virtual network for connecting the people. So that has to be managed. These VNFs has to be managed. Like, I'll give you an example. What happens if one network function goes down? This EMS knows this network function is going down or it is getting overloaded. It has to communicate to the VNF manager. So the VNF manager can say, oh, okay, now I need to instantiate one more new network function to keep up with the load. So it will say to the infrastructure, hey, go and give me the virtual resources so I can deploy one more network function. So the virtual infrastructure goes and it gives one more VM to the next level. Then the VNF manager tells this EMS, hey, create one more instance so that new load can be taken care of. So you need a virtual network function manager that has an intelligence of understanding the virtual network functions of telecom virtual network functions and able to do things and instruct the level below to ensure the network is able to run 24/7. So that's what is called as the virtual network function managers. Now, on top of that, you have orchestrator. Now, the orchestrator is nothing but which orchestrates everything together, right? Like, for example, I wanted to build a network for an enterprise. Just take an example, right? So what will I do? I go and design that network, and then I wanted to push that in. It's called as like, when I design the networks, I design the networks using, these are all the descriptions. I design everything, and then I push it on to orchestrator, and then orchestrator basically kind of push it down, and the complete network has been available and ready for the user to use it. Now the user is using this network. Now when the user is using that network, right, there are a number of times what happens is one VNF will go down, another VNF will come up. It will impact the services, the next level layer. This VNF manager, deals with only the VNF layer, right? You need one layer above which can look at the end-to-end picture. And it can orchestrate, okay, for the service, I need an end-to-end network. And in that, one VNF is going down. So let me tell the VNF manager to fix that. And VNF manager also, tell VNF manager to instantiate new VNF in the new service that I wanted to deploy. and manage the life cycle. If one service goes down, how do I bring in the another service? So some of the words that you need to remember, right? So life cycle management, right? You need to ensure that the complete service life cycle is taken care of. So the life cycle is applicable in all the layers. So you need to make sure the hardware, like this layer also, the life cycle is taken care of, right? From instantiation to termination. You need to also take care of the life cycle at the VNF level is taken care of. You also need to make sure that life cycle at the service level is taken care of. Then the second one is orchestration. So orchestration is nothing but ensuring when the system is running, it continues to run smoothly, right? How do you make sure that orchestrator continues to run the system successfully? It need an input from OSS system, right, and BSS system, because the OSS system is the one which basically provides you visibility of what exactly is happening on the network. So that input orchestration, if requires, right? If orchestration knows that input, then it would be able to better manage everything. And the same thing, it requires an input from BSS, whether this user is paid for this user or not, this service or not. So it can orchestrate, right? So the orchestration is like, think like a big, our grandfather, right? Who makes sure the whole family is running smoothly, right? End to end, everything is happening and instructs the VNF manager, virtualization infrastructure manager. Sometimes it instructs virtualization infrastructure manager through the VNF manager. Sometimes it instructs directly, and it gets the data from OSS, BSS. It also takes the input to, deploy the network fresh and make sure it's running continuously 24/7. So this is very, very important for you to understand. Why? Because again, connecting to the Magma context, most of the time Magma will be deployed in OpenStack. And if you're going to deploy Magma in some of operators' environment, right, they will expect Magma to work together with their existing VNF managers. But if you're doing a private deployments like FWA deployment and enterprise deployment, maybe you can just get by with Kubernetes and OpenStack, right? A standalone deployment for those private networks. But when you wanted to deploy the networks that has to be interoperable with the telecom operator networks, then you might have to start thinking about how to manage the Magma VNFs, how to integrate Magma to the VNF managers that are out there from different vendors, how to integrate the VNF managers to the OSS BSS, how to integrate VNF managers to the orchestrator, in addition to how to integrate Magma to the radios and transport. You also have to think about how to integrate Magma around all these infrastructure. It's very, very important. Okay. So this is a storyline, right? It's kind of pretty straightforward. Whatever I explained is what is here. I'll just run through this quickly. So what happens is the OSS and BSS system, when a user comes and asks for the service, what happens is the OSS BSS system understands this is what user asks, right? So what they do is they request network service and VNF lifecycle management, forwards NFV related request, policy and data, NFI capability. So basically from here, what happens is it tells the orchestrator, hey, this is what the user wants and please do it. Now, before that, if it is a new network, you need to also send the design to the orchestrator so it can set up the new network, like I explained, right? So those are the two inputs, operation inputs and the new design inputs goes to the orchestrator. Right, and then orchestrator is the father, which makes sure that it requests the VNF manager, visualizes the infrastructure manager to allocate the resources. And then the VNF manager manages the VNFs and takes care of this layer. So whatever I explained, it's kind of explained in bulleted points here. I will put this resume in the Microsoft, put this presentation in the Microsoft Teams, so you can always read through that. But whatever I explained at a high level, that's what it is available here. So end of the day, why do you need this network function virtualization? Like I told you, for a number of reasons: innovation, easy to manage. You can move hardware. See, physical hardware you have to move hardware from one location to another location by transporting. If it is virtual, you already have the data centers everywhere. You just move the network functions wherever you need. You can security, you can improve the elasticity, you increase the load if it is required, reduce the load if you don't. There's a lot of advantages, right? These are all on the papers, but in practice, it brings in a lot of advantages. Okay. Now, what is another important thing is, okay, you know what? I don't want to hurry up. because this is a little bit, these two slides are a little bit important concept. I will take it in our next bi-weekly session. It happens in 2 weeks. Then we will get into the cellular, try to understand the networks of different cellular networks and get into a little bit more details on the protocols. And once we finish this presentation, right, then we are ready to kickstart on learning Magma. Then you will understand easily Magma. Why is it designed? How is it designed? And things like that. Okay. So I will stop here. We have 4 minutes to close this call. Any questions from anyone? Did you guys learn something today? Are you okay?
Yeah, this was amazing. Thanks, Kaza.
Right. So what we will do is like one more session we will have, which will kind of help us to understand the basics. So once we have that basics done, then we will deep dive into Magma.
Yeah.
Okay. And then we will start learning Magma architecture and how it is actually designed, what are all the different components, and then we will start learning deployment of Magma in Amazon and many other things, right? We will start learning all these things together.
Yeah.
Right.
Sure.
So because I want to ask you something, I mean, today we have all the artifacts required to deploy Magma in AWS. Can we start, building artifacts that are we can deploy it in on-premise, but also on Azure and Google Cloud and things like that. Is this something that you guys are working on with Parthiban and team?
I guess Parthiban is working on to deploy it on OpenStack. I'm specifically talking about Orchestrator. But no, we are not working on to Azure and Google Cloud. But yeah, we are working on to deploy on OpenStack.
Okay. I think we need to go one step after another, right? But you are working together with Parthiban and team to do that anyways, right?
Yeah, I guess so. Subham is taking care of that.
Yeah. Just want to make sure that you are involved, right, with the team, because I don't.
Yes. Yeah, I know.
Yeah,
What's
because
going
I don't kind of do with you anymore, right? So from the learning point of view, so please make sure that. Awesome.
Yes.
All is good. So any questions from anyone, Bean, Javier, Sammy? Please join next. This happens bi-weekly. So go to Microsoft Team. Go to the Eventbrite, right? You can actually see that in Eventbrite. So the next session is going to be on
The 4th.
When is it?
December 4th.
December 4th.
Yeah, the 4th of December, right? So 4th of December, we will complete the basics of telecom and we are ready for 5G. Then 18th of December, what we will do, we will decide, should we have 18th of December or should we kind of start from the new year, right? Because this time the holiday season starts, right? So maybe we will try to, we'll decide that in our next session together. Okay, but I want to make sure that we have a telecom basics intro set, in our Jack in the box, so we are able to jump right into Magma and start learning the Magma architectures and so on. All right.
Yes.
Perfect. Sammy, are you into Magma Slack already or not?
In the Slack, yes, I am in the Slack.
Okay.
But I didn't use it already.
You might have already learned about Wavelabs, right? I work for Wavelabs, so we support Magma community in developing 5Gs and things like that. Feel free to support us and learn more. We need a lot of help as and when we get more work. We might require your consulting services. That's why I asked you to send your resume to me.
Yes, I have just sent you on your email on Wavelab. Yes.
Yeah, no problem. I may not have the requirement right now, but I want to make sure that I understand what you do, what are your capabilities. So when there is a requirement, I'm able to pull you in, right?
Yes, I was involved in the machine learning.
Phone number and Sammy's email address. So if you can add him into the Microsoft Teams and get him access to the Microsoft Teams and also add him into the WhatsApp, that would be good.
Yeah.
Thank you.
I'll do that while the code's on it.
Awesome. So till now I have not been able to get introduction from Javier and Bean. I hope next time when you join in 2 weeks, you will prepare yourself to unmute and introduce yourself to me. It would be really good to know with whom we are learning together, right? So with that, let's close the call for today. We are top of the hour. You guys have a wonderful day and talk to you all soon. Bye-bye.
Thank you.
Thanks, Vardhan.
Yeah, bye.
Vikas, are you joining this DevSecOps?